Helicopter landing gear is not that complicated, especially when you compare it to some of the stuff on the fixed wing aircraft, but it's still got a few unique things that we've got to cover, and it's got a couple of different styles that we can incorporate. So we're going to talk about skids, floats, wheels, and skis, and then a couple of features of all of those. So the most common, the basic type that you're used to seeing is skid landing gear. That's just the basic frames across the bottom here. So these are the skid tubes, and then running this way, those are the cross tubes. And that what makes up the just the basic, simplest type of landing gear that you see on a helicopter. You're going to see low skid gear, high skid gear. Quite often, the same aircraft can have different configurations. The Bell, for example, can have low skid gear, high skid gear, ultra high gear. It's all customer option depending upon what the operation is doing. You'll see some private operators and small businesses, they may choose to use low landing gear if they're going pavement to pavement. But commercial operators, utility operations, most operators in Canada tend to run their helicopters on high skid gear. It provides better ground clearance when they're landing in unimproved sites. Also provides a greater safety margin between the rotor system and their passengers. So you'll see it more common. Now, skid landing gear looks like it's really simple, and it really is. The cross tubes themselves, running right across here, the cross tubes actually are designed to flex. So even though the cross tubes look like they should be just a one piece tube, they are, but they're actually designed to flex along the length of the tube. So as the weight is applied to the aircraft in those locations, the tube will flex, and so the deflection, the distance between these 2 points, will actually increase. You might remember when we were doing the lifting and the jacking exercises with the helicopter, the landing gear spread as we put the weight back onto the aircraft. The skid tubes, oops, let's do this. There we go. The skid tubes, on the other hand, they're a little bit more rigid. Now, most of them are just a round tube, but there are some fancy ones like this from Dart Aerospace with the I-beam inside. The I-beam compared to the round tube is going to make the tube much stronger, but the penalty is a higher weight for the skid tube. The mounting for this landing gear is actually really simple. Most aircraft, like the Bells for example, they just used a simple strap across the bottom here. And so really there's just a handful of bolts holding that landing gear on when it's mounted. Because all of the flex, all the shock absorption is happening in the cross tube, then this mounting here can actually be fairly simple. Robinson, McDonnell Douglas, on the other hand, their skid tube, their cross tube, pardon me, is made up of multiple pieces. The flexible portion on the cross tube, so this is looking at the rear landing gear of the R-22, and the rear cross tube, the aft cross tube, the center section here is flexible, but the down tube portion of the cross tube going down to the landing gear is more rigid, and so in that case the mounting point here has to have bearings on it that will allow the flexible points in the landing gear to move. So same thing, the landing gear is going to spread, the landing gear is going to have that deflection, but we need to have a flexible, or we need to have a bearing mounting point for that landing gear to move and to work. Now, there's a couple of different things we can add to fixed or skid landing gear, and one of them is called pop-out floats. So there's a couple of rules in aviation, and if you've got a single engine helicopter like this Bell 206 and you're flying out over open water, you have to provide a means to either safely land on the water, or you have to fly so close to shore that you can glide to shore or close to shore. So what operators will do, especially in coastal environments, is they will use pop-out floats. Pop-out floats are designed in case of an emergency. There's a couple that are designed for reuse, but most of them are designed strictly for emergency use. And if you have an engine failure, the pilot has a trigger inside the cabin, usually off of the collective, and they can pull the trigger and that will inflate these floats. They're usually inflated with high pressure nitrogen or high pressure helium, and they inflate pretty quickly. I've put a couple of videos up in the course. Go watch them. You'll see the landing gear inflate. You'll see this one and this one. In fact, this one, you've got the video for this one, and right here, there's the nitrogen bottle right on the bottom, and then you can see the lines running down the sides of the skid tube. So when the pilot triggers them, the bags will inflate out of, or the floats will pop out of these inflation here. Um, when you see the video, sometimes you'll notice a bit of a white powder. That's talcum. They put some talcum powder inside the float bags here, so that way obviously if they get moist or anything like that while the aircraft is flying, we don't want mold or anything like that to form inside the landing gear. So you'll see that little bit of a puff of white come out. It's just the talcum powder when the floats go out. So anyways, go watch those videos so you don't have to just listen to me. You can actually see them pop out and go from there. They do have to be tested on regular intervals. That's the fun part. The bad part is that there's usually some poor apprentice that's got to go pack them up afterwards. That'd be you. There's also fixed floats. So fixed floats are, if you've ever had anything to do with like a Zodiac boat, a fixed float is the same thing. They're a bag. They're usually made out of a rubber and fabric material, and these are inflated with air, typically low pressure. So that means they're only going to be filled up with a couple of psi. Now, fixed floats are great for landing on water, but you'll also notice, like in a spot like this, they can also be used for landing on snow or in something like this in ice. So they're going to distribute the loads out. Fixed floats have a couple of challenges with them. Obviously, you've got the whole issue with this just being a float on the bottom here, this being a rubber bag. So you've got the abrasion issue that you have to deal with. The other thing is that if you change in altitude very much, so say you're flying in the mountains, you go from the valley bottoms up to a high glacier, in that case, you can run into an issue where the float may overpressurize, and then as you climb up, the float will actually have to start venting air. That's fine as you climb up, but when you descend back down into the valley again, the float may lose some of that volume of air, and therefore it's not going to hold pressure. There's a couple of different configurations. There are some where there is a rigid cross tube still on the bottom, so you'll have a rigid cross tube, and then the float bag on top of that. Okay, and so in that case, you've got the cross tube protecting the float. In other cases, you'll have the float on the bottom and the cross tubing support on the top. Both work fine. However, this latter version does have a greater abrasion problem. Now, on skid tubes, one of the things that they'll put onto the landing gear is called bear paws. So I've added a couple extra pictures in here that aren't on this other slides, just just because I don't have the one to walk around in the classroom with. And this is the bear paw right here. You'll see a couple of different styles, a couple of different examples. Bear paws, they're one of Canada's gifts to the aviation industry. When they started running helicopters in the bush, one of the problems was that when they land on soft ground, the skid tubes would sink into the snow or into the mud. And so what they originally did, the original helicopter pilots, what they would do is they would take snowshoes, attach the snowshoes to the backs of the landing gear. The reason they're mostly at the back of the landing gear is so when the aircraft lands in the soft ground, the belly and the nose of the aircraft might still sink, but the bear paw is going to keep the back of the aircraft up, provide a little bit more flotation at the back of the landing gear, and that's going to keep the tail rotor out of the mud or out of the snow. So it's not still going to sit flat, but it will sit in a position that's still safe for flight. The other thing that we'll put onto the bottoms of the landing gear is called skid shoes. That's why I put the same picture on here. In fact, on this picture here, oops, bear with me here. On this picture here, you can see the skids right across the bottom here. You can see all these little pieces along here. And the skid shoes are sacrificial pieces of metal that go across the bottom of the skid tube, because when you're landing on pavement all the time or rough ground, then the concrete against the skid tube would eventually wear a hole in the skid tube. The skid shoe is designed to be a sacrificial piece on the bottom of the landing gear, and that way if the aircraft lands, or when the aircraft lands on those pieces, the skid shoe is going to take the abrasion, and the skid shoe is going to be the replaceable part. It's the skid shoe that you're going to replace instead of the entire skid tube. There are helicopters out there with wheeled landing gear. I'm not going to go too much into the wheels themselves. That's the systems are the same as on fixed wing aircraft, and if you haven't already, you're going to take a bunch of classes that's going to talk about that. The reason we put wheels, you typically only see wheeled landing gear on larger helicopters. So the reason we put the wheels on there are the used wheels. Obviously, it's going to aid in ground handling. It's also going to make the helicopter able to taxi away from the airport, or from the hangar, pardon me. And so you can get the helicopter away and then you can take off at a safe distance. The other advantage, the other reason they use wheeled landing gear is on some of these larger helicopters, it allows you to do what they call a low power takeoff, where the helicopter can take off from a move, like a rolling, like an airplane takeoff, can actually go through translational lift while it's on the ground, and then can climb out using a lower power setting than if it was to take off straight vertical. On a smaller helicopter, that's not a big advantage, but on a larger helicopter, the difference, the fuel burn alone, could be substantial. So you can use it for those things. So for rolling takeoff and also for taxiing, not necessary on a smaller helicopter. There are some helicopters out there with skis. It's not a very common option. You can just make the skis out right here. This obviously on a Chinook helicopter. They're not very common. Typically, if you see a helicopter with skid landing gear, we would just put on bear paws onto it. You won't see too many machines with skis out there, but I just had this picture, so I thought I'd throw it in there just to add to it. Cable cutters. Now, I'm bringing up cable cutters now because cable cutters have obviously that lower tube is going to have a reason with the landing gear. What some of them have back, you can see this skid tube here, how it sticks out of the front and creates that hook. What manufacturers are starting to do now, and we talked a lot about cable cutters in the beginning, but one of the reasons I would bring it up now is some of the manufacturers here, you'll notice how they've attached the front of the skid tube. So the skid tube here doesn't stick out. Let me just go. Manufacturers like Airbus have started to do is mount their forward cross tube directly into the front of the skid tube. And what that does is it creates a smooth transition, a smooth surface across the landing gear. So if you do have issues with a cable or anything like that, it's not going to snag on the landing gear. It makes the landing gear a safer design. Ironically, the picture I'm showing you with this EC120, because they have the camera mounted right here, that's why they need the lower cable guard. Without the camera, they could effectively go without the cable guard, or it would be less important that they had that lower cable guard. The top one is still important because of the rotor system. Now, I've also put a bunch of videos in the course about ground resonance. If you haven't watched those videos yet, go watch them. There's 3. I'll wait for you. Go watch the videos. Okay, you done? They're worth it because you're going to watch 3 helicopters, or 2 helicopters at different angles, rip themselves totally to pieces. What ground resonance happens, or what happens with ground resonance, sorry, is that when the helicopter is running on the ground, if something's to occur where one blade will lead and another blade will lag and moves the center of mass of the rotor system away from the center of rotation. If that is to occur, then the aircraft goes into ground resonance and proceeds to rip itself apart. The correction for it, in one of the videos, you'll notice that the helicopter starts to vibrate on the ground and then they pull up off the ground and get out and then fly away. What's happening there is if you can get the aircraft back into flight, that loads up the rotor system and forces the center of mass back near the center of rotation and eliminates the vibration. However, if you can't do that for whatever reason, then you're committed into ground resonance. If you can't, then it's going to happen. So you may have noticed I've given a hint here. This is occurring on blades that can lead and lag. So that means ground resonance is going to occur on aircraft with fully articulated rotor systems. It's not going to occur. It's not going to be the same problem on a rigid or on a semi-rigid rotor head where the blades don't lead and lag the same. But a fully articulated system, anything where the blades can lead and lag, that has the potential for ground resonance. So I've got a couple of causes in here. Main rotor blade dampers, because remember the main rotor blade damper is what's keeping that blade or limiting that blade from leading and lagging. If there's problems with the landing gear, so unfortunately, if you've got wheeled landing gear or something in some kind of dampening system in the landing gear that has failed, that may actually induce or cause ground resonance to occur. So both of these can be maintenance related, is why we've got to watch for them. The last one here, pilot-induced oscillations, well, that's up to the pilots to eliminate those problems. There you go. Have fun.